Take a look at a couple other questions here. Question number 10. So I'll take care of some of those there. Same page. I have a whole bunch of mixed up questions here. So I have question D, let's say, because that looks difficult. So I have all this to the power of, -2. All this to the power of -2, and it's a big fraction. There's 2ab c cubed, and over here I have 2a squared b cubed c all squared. Okay, so again, don't start messing around with this thing over here. I would leave this to the very end. Okay, I'm going to simplify what's inside of the bracket first, because remember, bedmass, brackets, exponents, so take care of what's inside the brackets first. So that's what I'm going to do. Now I'm not going to start dividing this because on the bottom I have a power of a power rule, so I'm going to leave 2abc cubed here, but I'm going to take care of all of this. Remember, this is just one item to the squared, so it's everything squared. That squared, that squared, that squared, and that squared. So first I have to do 2 squared, so I'll just write 2 squared. I do a to the power of 2 all squared. A to the power of 2 all squared is the power of a power, that's a to the power of 4, right? 2 times 2. B cubed all squared, that's a power of a power, that's b to the power of 3 times 2 is 6. And c squared is just c squared. Okay? Now, some of you would have done the 2 squared right away and just written 4. That's okay, because obviously it would be one less line here, because this line would just be the exact same line, except 2 squared is 4. So 4a to the power of 4, b to the power of 6, c squared. Continuing this, I'm going to end up with dividing these two things with one another, and of course I'm going to leave this -2 as is. Now 2 divided by 4, I'm not going to write 0.5, I'm actually just going to leave it as a fraction. 2 over 4 is the same as 1 over 2, right? Because that's just a half, right? Both are divisible by 2. A to the power of 1 divided by a to the power of 4 ends up being a to the power of -3, because I do 1 minus 4. Okay. B to the power of 1 divided by b to the power of 6 ends up being b to the power of -5, because 1 minus 6. And c to the power of 3 divided by c squared ends up being c. Now some of you may argue you would do this a different way. Okay, so I'm going to go this way for those who would have done this a different way. See, some of you would definitely agree with me and do 2 divided by 4, okay, yeah, it's a half. But some of you would argue that if you did a to the power of 1 divided by a to the power of 4, if you cancel out a's from both top and bottom, you can actually cancel out an a from both top and bottom, right? An a here divided by one of the a's there is going to leave you with a's just left on the bottom, and there's going to be 3 of them, which is exactly the same as this. So one can argue that you'd write that, which is perfectly fine. Just like b to the power of 1 divided by b to the power of 6, if you canceled out b's, you would have none left at the top and 5 of them left at the bottom, which is exactly that anyways. And same with the c's, c cubed divided by c squared. If you canceled out c's, you can cancel out 2 of the c's from both top and bottom, and you'd be left with just 1 of the c's at the top. So one can argue you go from this step to this step, which is totally fine. Coming back to here though, once I got to here, over here, this thing here, you have a choice of rewriting that, or you have a choice, of actually doing this -2 exponent now. Now -2 applies to both top and bottom of this function, of this thing here. So you can actually go, this 1 doesn't matter, but if you go a cubed to the -2, that is a power of a power, you're going to leave it as a, and -3 times -2 is 6. B to the -5 to the -2, that is b to the power of +10, because -5 times -2 is +10. And then c to the power of -2 is just c to the power of -2. And then 2 to the power of -2 on the bottom is 2 to the power of -2. And then you'd have to clean this up, because the final answer cannot be written like this. The final answer has to be written in proper form. That's okay at the top, the a to the power of 6. The b's okay, b to the power of 10. The c's not okay because it's to the power of -2. That just means put it on the bottom of the fraction to the +2. And this 2 on the bottom is not okay because it has a negative exponent. So what does that mean? It means flip that to the top and write it to the positive 2. So the final answer would just be 4 a to the power of 6 b to the power of 10 all over c squared, because 2 squared is 4. If you went about it this way, that's fine. And then some of you may say, okay, well, since I have no negative exponents here now, an easy way to get rid of this negative would be to rewrite this as flip the, I'm going to flip this fraction, because this to the power of negative 2 is the same as this to the positive 2. And that's fine as well, because your rule for a negative exponent, if you just want to take care of the negative, is flip the fraction upside down and write it to the positive 2. And that's perfectly fine as well, so you don't get trapped into the negative exponents. Continuing this, same thing, everything squared, both top and bottom. So 2 squared, I'm going to do that right now, is 4. A cubed all squared is a to the power of 6, because cubed to the power of 2, that's just power of a power. B to the power of 5 to the power of 2 is b to the power of 10, that's power of a power, and c squared on the bottom. So either route is okay. So there's obviously little routes within the routes. So either route is okay. Now let's take a look at a couple others. If I take a look at, let's say number 10, number 10F. Number 10F states this: the sixth root of 8x to the power of 6, all squared in here, all over the fourth root of 625 x to the power of 8. So let's take a look at this one here. So this one here is a little different. Now you have square roots, powers of powers, and all that stuff. And I'm going to take care of this all in one shot. So not in one shot, but one thing at a time. So let's first just leave this alone, this 6, the root 6, and let's actually take care of this square, powers of powers, right? This is 8 squared and also x to the power of 6 all squared. So 8 squared we know is 64, and x to the power of 6 all squared is x to the power of 12. We know that because that's a power of a power. Over here, there isn't powers of powers. This is just the fourth root, and this is just one item, 625 x to the power of 8. So that's the first thing I took care of, the stuff inside there. Then I'm going to rewrite this stuff. This stuff here can be rewritten. See, this 64 x to the power of 12, the sixth root actually means to the power of a sixth, right? The sixth root means to the power of a sixth. So that's how I wrote it. And over here, 625 x to the power of 8, the fourth root actually means to the power of a quarter, right? The fourth root is to the power of a quarter. So it's all this to the power of a quarter. So that's what I wrote there. Continuing this, now this is a power of a power. So this is 64 to the power of a sixth, and that's x to the power of 12 to the power of a sixth. So when you have a power of power, you keep the base the same, and 12 times a sixth is 12 sixths. Okay, so I have 64 to the power of 6, and obviously that to the power of 6. Same thing here. This is 625 to the power of a quarter, and also x to the power of 8 to the power of a quarter. So that would be x to the power of 8 times a quarter is 8 quarters. Okay, so you have to remember that that sixth and that quarter applies to both things in there. So if you continue this, you're going to have, now it's very important that you understand that you can rewrite this back to the sixth root of 64, and over here this ends up being x to the power of 12 divided by 6 is just 2. Okay, so you're just taking the sixth root of that number, and then this just is x squared. And this is the fourth root of 625, and x to the power of 8 quarters is x squared also, because 8 divided by 4 is 2. So now is where you start using your calculator here. So as long as you know how to use your calculator, 6th roots and 7th roots, all that stuff, you have to know which button. Some of you have to press the button first. Okay, so some of you have to press the 64, then the button, and then the 6. Some of you others have to press the 6, then the button, then 64. The button should look something like this, the x root of y. Okay, so when I take the 6th root of 64, it's actually 2, because 2 times itself 6 times, or 2 to the power of 6, is actually 64. And when I go to do the 4th root of 625, that ends up being 5, because 5 to the power of 4 is 625, x to the power of 2. If I continue this, this ends up being still 2 over 5, and x squared divided by x squared is just 1, or just x to the power of 0, which is 1. So this, or that divided by itself, is gone. Either way you want to think about it. Don't write x, because x squared divided by x squared, anything divided by itself is just 1. So x squared divided by x squared is actually x to the power of 0, which is 1. So the final answer is 2/5. Okay, very good question there.